All right, sixth graders, this is from lesson 10.3. In lesson 10.3, we talked about properties of numbers. Remember some of the properties we talked about?
Oh, yes.
Oh, what was a property? Yeah.
The commutative property?
The commutative property, yep. Commutative property that you can switch the numbers around and still get the same answer. What operations does the commutative property work for? What operations can you use the commutative property for? Merlin? Multiplication and addition, right. Multiplication and addition. The properties of zero. What are the properties of zero?
Like any number times 0 equals 0.
Yeah, any number times 0 equals 0, and someone, come on, everybody, get involved. Go on. Not divided by.
Addition.
Addition, right? What's addition? Yeah, it is. Yep. It's the identity property. So any number plus 0 is that number, right? Now there's also another identity property. Sam?
Any number times 1 equals 0.
Right, any number times 1 equals itself. Yep. And we also talked a little bit about the associative property. What is the associative property?
The associative property?
Yeah, the associative property.
Like where you switch
The order in which you do the operations. So instead of multiplying 4 times 25 first, multiplying 6 times 25 first. I don't know why you do that, but it sure makes sense to do 4 times 25 first, because that makes 100. But the point is that you can switch the parentheses and get the same answer. Okay? And then finally, we worked a little bit with reciprocals. And we talked about reciprocals. What does a reciprocal do? Great.
It's reciprocal times another reciprocal will equal 1.
Yeah, the product of two reciprocals equals 1. A number times its reciprocal equals 1.
Plus its reciprocal.
Okay? No, there's no plus for reciprocal. Alright? It only works for multiplication. So we use these ideas to simplify and to compare numbers. For example, we can simplify this expression, and what do you notice? What do you notice in this one? Gracie?
That they're reciprocals.
Yeah, they're close to reciprocals. You notice that 13/18ths and 18/13ths are reciprocals, but this one is negative, so it makes it -1, and then times 5, which is -5. We use the concept of reciprocals to simplify this. We also use the concept of what? Which one switches the order of the numbers? Other one. Lily has it. Commutative, right. Commutative. Let's look at these sample problems from yesterday. Which concept can we use for these? I guess this one uses one we didn't talk about in the properties, except the commutative property. How can we use the commutative property here? Changing the order. Would it make sense to add 1/4 plus 3 2/3 first?
No. 1/4 plus 1/4 plus -1/4, and then plus 3.
Right. 1/4 plus -1/4. So we can switch the order here. And these, what are these numbers called?
Fractions.
The other fractions, yeah, but, well, they are, remember when we talked about the number lines?
No, that's not right.
And The same distance on the other side. They're what?
Opposites.
They're opposites. Yes. When you add opposites, they equal 0.
Yes.
And then we're left
I
with
knew that.
3 2/3. All right?
Whoa.
Yeah. What about this one? What property are we using, Adam? The 0 property. What else? There's the 0 property of multiplication. What else is in this? Should we do this first?
No.
No, that doesn't make sense to multiply this first and then multiply it by 0.
It's gonna be 0.
Right? It's going to be 0. So if we multiply it by 0 first and then multiply it by 0 again, that equals 0, right?
Yeah.
Yeah.
Now, how about this one? What property does this use, Asa? Number 3. No, look at the numbers. 1/2, 4 3/5, 2. How about 2/1? Those are reciprocals, aren't they?
Yes.
And so, should we do 1/2 times 4 3/5 first?
No.
No, let's change the order. Multiply the reciprocals. And what do we get? Johnny? 2 times 1. No, I'm sorry. 2 times 1/2 is 1 because those are reciprocals. 1 times 4 3/5 is and 4 3/5. Yeah.
Oh my gosh.
The number itself, right? 1 times itself. What concept is this one?
It is.
Trinity? They are reciprocals, aren't they? Negative 3/7, negative 7/3. All right, that's 1 times 1. 1. Right? How about this one? What can we recognize here that's going to help us to figure this out without even doing the multiplication? Gracie.
The first one has 1 negative, so it's going to be negative.
So yeah, the answer to this is negative. The answer to this one is positive. Which one has to be bigger?
Positive. Positive.
The positive has to be bigger. Right. So the left side is less than the right side. How about this one? Merlin. What concepts are in this one? What concept here? Why are they equal? Yeah, because this is what? This one is 17/4, and this one is 17/4. So what property is demonstrated here? Reese, you know, you said it before. Commutative, right? The order is different, but they are equal. Right? Yep. Okay, let's move on to operations. The order of operations. Right? Yeah. Number 8, 200 divided by 4 squared minus 2.5 plus 8. What should we do first? Max?
Exponents.
Exponents first. Let's simplify the exponent. What is this?
That is 16. 16.
It's not 8. It's not 4 times 2. It's 4 times 4. Right? Then bring down what's left. Now what should we do?
The division.
Can we pick what to do next?
Order of operations.
No, we have to use the order of operations. We have to do division next.
Division.
What's this?
12.5.
Good. 12.5 minus 2.5 plus 8.
Which would be 10 plus 8 equals 8.
Right, and then we have to go from left to right.
Oh my gosh, I got it right.
Okay?
I got it wrong.
I was close.
Close.
12.5, I got that.
Any questions here?
12.8. Oh, it's an 8. Okay, but we didn't have it right.
All right. Use these ideas, use these properties, and the order of operations to help you figure out, compare numbers, and to simplify